Hi, I'm going to share some ideas on design patterns. There are 23 design patterns which can be categorized into three categories: creational, structural, and behavioral patterns. The creational design patterns abstract the instantiation process. They help systems independent of how its objects are created, composed, and represented. Structural patterns are concerned with how classes and objects are composed to form larger structures. Behavioral patterns are concerned with algorithms and the assignment of responsibilities between objects. Let's see each design pattern. Abstract factory provides an interface for creating families of related or dependent objects without specifying their concrete classes. Here, the client has the reference to the abstract factory class and abstract product interface. First, it will obtain the instance of a concrete factory object using the getFactory method inside abstract factory. The concrete factory object can be created based on some environmental variables or some arguments that the client can pass to the abstract factory. Once a concrete factory object is created, client can start creating products. The instantiation of specific product subclasses depends on the concrete factory. Here, concrete factory 1 creates product A1 and product B1, whereas concrete factory 2 creates product A2 and product B2. For example, in an application, we need to implement different UI themes according to the user preference. If the UI theme changes, then every UI element style will be changed. This functionality can be implemented by abstract factory pattern. Say, if we want to implement light and dark themes and we also anticipate more themes that will be added in the future, then we can create a parent class abstract theme factory. Then light theme factory and dark theme factory will implement the abstract theme factory. We can create an interface for text box, label, and button. Then we can create a class light text box and dark text box implementing text box, light label and dark label implementing label, and so on for all UI elements. Then the client one which creates the UI will fetch appropriate concrete theme factory according to the user preference and create the UI. A real life example, suppose we have two spice boxes which consist of many compartments. In one spice box, we have all spice powders from one brand, and in another spice box, we have all spice powders from another brand. Also, whenever we cook, we use every spice powder from one brand only. That is, we do not take one spice powder from one spice box and another from another spice box. Our friend chooses a spice box for us. This can be seen as an abstract factory pattern. We are the clients, our friend is the abstract factory, the spice box is the concrete factory, and the spice powders are the products. Builder separates the construction of a complex object from its representation so that the same construction process can create different representations. Here, in order to create the product object, the client uses the builder, which has several methods that will build part of the final product and has one method that will return the final product. For example, we want to create a library that will be used to make HTTP request. Here, creating an HTTP request is complex since we have to specify various details like protocol, domain, path, request headers, cookies, etc. Here, some of the details use some default values and some details are optional in an HTTP request. So, instead of having separate constructors in the HTTP request class with various combination of arguments, we can use the builder pattern to create HTTP request objects. The HTTP request builder has methods like add header, add cookies, etc. And these methods, which are used to create part of the final product, will return its instance for chaining purposes. The state of the partially built object is maintained in the builder instance. Finally, the get HTTP request method will return the built HTTP request object. A real life example, some shops will sell customizable ice creams. We can choose the flavor of the ice cream. We can add different choices of nuts, add creams, etc. This can be seen as the builder pattern. We are the director, the shop is the builder, and ice cream is the product. Factory defines an interface for creating an object but let subclasses decide which class to instantiate. Factory method lets a class differ instantiation to subclass. Here the subclass concrete created actually instantiates a specific concrete product which will be used in the operation. Inside perform operation we refer to the interface product which defines the operation common for all concrete product. For example, in an application, we have to implement some data processing functionality. First, data content will be fetched from a data source and we do the processing. Data can come from a database or file system. Here, we can use the factory pattern We can create a data source interface, which is a product interface. Then we can create two classes, file system data source and database data source, implementing data source interface, which are the concrete products. Then we can create a data operation abstract class, which is the creator, which will contain the perform operation method. We can have two classes, database data operation and file system data operation, which will override get data source and return corresponding data source subclass objects. Inside perform operation, we first fetch objects returned from get data source and perform the operation. A real life example. Suppose a cook wants to prepare tea for a family of two members, say person A and B, where person A likes tea when it is made with tea brand A and person B likes tea when it is made with tea brand B. Here, tea recipe is the same regardless of brand of tea powder. Here, the cook is the creator. When person A asks for tea, the cook uses brand A tea powder, that is one concrete creator, and when person B asks for tea, the cook uses brand B tea powder, that is another concrete creator. The purpose of concrete creator is to select the right tea brand. Here, tea powders are the products. Prototype. When specifying the type of objects to create using a prototypical instance, new objects can be created by copying these prototype instances. Here, the client provides specific concrete prototypes to the driver class, which will use the prototypes clone method to create as many similar objects as required. For example, for the same light and dark UI theme example, when we have a different requirements where we need to use text box from light theme but label and button from dark theme, in the future there may be any number of combinations. For 3 UI elements, we have 8 combinations. When the number of UI elements is more, number of combination increases. We cannot create a concrete factory for each combination as in abstract factory pattern. So here we can use the prototype pattern. We can create light label and dark label prototypes implementing label interface. Likewise, we can create concrete prototypes for each UI elements. Now, we can create a form with any combination of light and dark UI elements easily by passing appropriate prototype objects to the UI creation code. A real life example. In a hotel, the recipe for all dishes will be provided by the head chef. Whenever the junior chefs responsible for cooking the dishes as a food order is placed, he or she may follow the same recipe for the dish. Here the recipes are the prototypes. Singleton ensures a class has one instance and provide a global access point. Here, the singleton class has only one instance, mostly created lazily when that one instance is accessed, using the static method which will create the single instance if it is null, otherwise it will return the single instance. The single instance is maintained inside the singleton class using a private variable. Singleton class has a private constructor so that it cannot be instantiated outside the class. For example, in an application, we will create only one database connection and that will be responsible for performing all database queries for the entire application lifetime. Here, we can use a singleton pattern to get the single database connection object. A real life example. In almost all schools, there will be only one principal, so any request a teacher or any other staff has and that should be handled by a principal, it must be sent to the single principal. Adapter converts the interface of a class into another interface that client expects. Adapter lets classes work together that couldn't otherwise because of incompatible interface. Here, the client wants to use the library method, but when a client accepts a different interface, we can create an interface that client accepts and create an adapter class implementing the target interface so client can use the library method through adapter. For example, in an application, we want to display tabular data as a table or bar chart. We have a data display interface which has one method display data. We have two classes table data display and bar chart data display which implement the data display interface. In the display data method in table data display class, we have implemented our code to display the table, but for bar charts, we are going to use a third party library. Here we can use the adapter pattern. We can create a class bar chart data display in display data method implementation. We can invoke the library method to create the bar chart. The bar chart data display class is the adapter. A real life example. When we have an electronic device with US pin and when we want to connect to Indian plug point, then we need to use a US pin to Indian pin converter. Here the converter is the adapter. An electronic device with US pin is the one that needs adaptation. Bridge decouples an interface from its implementation so that the two can vary independently. Here, there are two object hierarchies. One is abstraction and defined abstraction, and the another is implementer with its subclasses. The refined abstraction has the implementer instance to perform an operation. The two object hierarchy can vary independently without affecting the other. For example, we want to create the form using different UI elements with different variations with different themes. Here we can use the bridge pattern. UI element will be the abstraction. Text box is one defined abstraction and it has two subclasses, simple text box and text box with help. Now, instead of introducing subclasses for each variation of subclasses like light simple text box, dark simple text box, which will lead to creation of many subclasses as number of UI elements and its variation increases. We create a separate object hierarchy for theme and we can pass the reference of concrete theme to UI element hierarchy. A real life example. In a coffee machine, we may have various coffee options like late, cappuccino, espresso, etc., which will have different proportion of milk and coffee decoction. We can use any variation of milk such as low fat milk, skimmed milk, and high fat milk with a coffee machine, as there will be separate container for milk that the coffee machine connects to. It is not a good idea to add many containers for adding different variation of milk in a coffee machine and provide options like skimmed milk cappuccino, high fat latte, etc. And also it will introduce tight coupling because if we introduce another variation of milk, we have to change the coffee machine. Composite composes object into tree structure to represent part-whole hierarchies. Composite lets client treat individual objects and composition of objects uniformly. Here, the component is the parent class. There are two subclasses, leaf and composite. Here, leaf does not have children, whereas composite have children. Inside the perform operation method, a leaf instance will perform its specific operation, but a composite instance will iterate through all the children and call perform operation on every child. If a child is a composite instance, then the call is made for all child's children and so on. For example, a file system may have folders and files. In order to walk the entire directory tree, we have to iterate recursively if a folder is found inside a folder. While walking the directory tree, we need an interface common for both file and folder. Here, we use the composite design pattern, where file system item is the component, file is the leaf, and folder is the composite. A real life example, there are many buildings. Each building will have many rooms. A room might have shelves. A shelf might have archives. An archive will have many files. This is a composite pattern where files are the leaf and buildings, rooms, shelves, archives are composites. While searching for a particular file, we have to search recursively through every composites. Decorators attaches additional responsibilities to an object dynamically. Decorators provide a flexible alternative to subclassing for extending functionality. Here, component is the parent class or interface common for concrete component and decorator. That is, there is no difference between concrete component and concrete decorator for the clients which accesses the concrete objects through component interface. Here, component will have a reference to another component. Decorator uses this instance. Inside the perform operation, a decorator adds some extra functionality before and or after calling the enclosing component instances perform operation method. For example, in an application where we create a form using UI elements, we have to include a feature to decorate some elements with box shadows. Here, we can use the decorator button. We can create an instance of box shadow class and assign the UI element that needs the box shadow to the instance's UI element variable. So, when form is created, we can call draw in box shadow, which will draw the enclosing UI element first and then it will add shadow. A real life example. While packing things, we add an extra bubble wrap for brittle things like glass and we put the other things directly inside a box. Here, there is an additional responsibility while packing brittle things. Facade provides an unified interface to a set of interfaces in a subsystem. Facade defines a higher level interface that makes the subsystem easier to use. Some clients may know how to use the system with its low level APIs, but some clients do not know it. So Facade creates a high level API for those clients for easy usage in addition to the low level API. For example, in an application, we have to create a PDF document which has to contain heading level 1, heading level 2, and a paragraph of text. Consider there is a PDF creation library that provides functionalities like adding a text with properties like font size, font face, font family, and text alignment. If some clients do not know how to set properties for heading level 1, heading level 2, and paragraph, we can create a PDF document creation facade which will include operation for adding heading level 1, heading level 2 and paragraph. Actually, facades are created with some assumptions. A real life example. Consider a shop which sells assembled computers. Some customers know about all the hardware components like processor, graphic cards, hard disk, monitor, etc., and know which combination works best for them. But other customers do not know which combination of which hardware components is best for their requirements. For them, shopkeeper can suggest one. Here, the shopkeeper is the facade. Flyweight. Using sharing to support a large number of fine-grained objects efficiently. Frequently used objects which do not contain any state can be created once and can be used in all places. Here, the client accesses the shareable objects through Flyweight Factory. The Flyweight Factory takes care of creating the objects once and maintaining the objects. Even the unshared concrete Flyweight instance is also created with Flyweight Factory, for which a new instance is created whenever the instance is requested. So that unshared concrete Flyweight can be converted to shared concrete Flyweight, and there is no need to change the client's code. Using enums is an example of a flyweight pattern. We have a variable player state in player class. When a player gets the turn, we want this variable as player state enum dot active, otherwise player state enum dot inactive. A real life example, some 10 persons playing cricket with only two bats instead of each one having their own bat. Here bat is the flyweight. Proxy provides a placeholder or surrogate for another object to control access to it. Here, both real subject and proxy inherits the subject interface. Then proxy has reference to the real subject instance. When a client handles the subclass instance of subject interface, it has no idea whether it is operating on a real subject instance or proxy instance. There are three usages using proxy objects. They are: if construction of real subject is expensive, then a proxy can be created as a placeholder until a real subject instance is created. If real subject instance is secure and must follow some access control, then access control can be done via proxy. It can also used for logging or reference counting purposes. For example, in a spreadsheet application, when a document is to be loaded with tabular data with 10 charts, all charts are not loaded while opening the document because all charts may not be in the visible area. We can place some dummy objects. Once the user scrolls and the element becomes visible, then real charts can be loaded. Another example is in a testing framework, mock objects are used in order to avoid class to be tested calling another class code. So mock objects are assigned to the dependencies of class to be tested. Whenever an operation is called on the mock objects, it does nothing, or we can configure the mock object to return some output. Sometimes we can also make mock objects call the real methods also. The mock also records how many times a particular operation is called. The mock object is a proxy. A real life example. When a student's close relative attends a parent teacher meeting, when both parents cannot attend the meet, the relative is the proxy. Chain of responsibilities. Avoid coupling the sender of the request to its receiver by giving more than one object a chance to handle the request. Change the receiving objects and pass the request along the chain until an object handles it. Here, handler has the reference to the successor. So when a client sends a request to be handled to some handler, the handler may handle the request and pass the request to the successor. The handler may not pass the request after request is handled. For example, in a web page, we can assign event handling to UI elements, say a click event to the button. So when a user clicks the button, click event handler configured will be called. Button click event handler may stop the event from propagating to the enclosing element. Otherwise, click event will be propagated to the enclosing UI element. If that UI element also configured the click event handler, then that handler is called and so on. A real life example, when we give a circular or notice about an event to people, people who receive the circular may not be interested in that circular, but they may know people who are interested. They may pass the circular to them. Here, the people who know other people are like the handler successors relations. Encapsulates the request as an object, thereby letting you parameterize clients with different requests, queues, or log requests and support undoable operation. Here, the client creates a concrete command object and configures the receiver object in a concrete command instance with data that must be sent to the receiver. Then, client assigns the command object to the invoker that executes the command object at a particular time. For example, in a Windows operating system, we can make shutdown request in two ways. One is clicking the shutdown button from the start menu or pressing Alt plus F4 on desktop. Both perform the same operation, but the event is triggered from different places. A real life example. In some TVs, we can find the volume increase or decrease button in the TV itself. When we do volume increase from these buttons or from remote, the same operation is performed. Interpreter. Given a language, defines a representation for its grammar along with an interpreter that uses the representation to interpret sentences in a language. Here, the client has the reference to the context and to the abstract expression. Client calls the interpret operation on subclasses of abstract expression, passing the context. For example, when we want to evaluate arithmetic expressions, we can define five simple grammar rules, that is addition, subtraction, division, multiplication, and brackets. Using these grammars, an arithmetic evaluator instance can be created. Then client calls evaluate on this instance, passing arithmetic expressions. A real life example, a translator who knows the grammar of two languages can convert one language to another language. Iterator provides a way to access the elements of an aggregate object sequentially without exposing its underlying representation. Here, the client has the reference to the aggregate subclass instance. In concrete aggregate instance, create iterator operation is executed to fetch iterator subclass instance. The iterator interface provides a method to get the current element, next element, to check whether iteration is completed. When iteration logic is separated from aggregate instances, we can implement various iterations easily. For example, in Java 7, when we call an iterator operation on a collection class, then we get a specific concrete iterator object based on the concrete collection class. A real life example, when a postman wants to deliver some letters in his area, he can vary the order in which letters are to be delivered based on number of letters to be delivered. If there are only 4 or 5 letters, he can order the letters based on the addresses as it will reduce the travel distance. When there are 100 letters, then the postman just delivers that in a random order. Mediator defines an object that encapsulates how a set of objects interact. Mediator promotes loose coupling by keeping objects from referring to each other explicitly, and it lets you vary their interaction independently. Here, concrete colleague has the reference to the mediator and mediator has the reference to the colleague. Whenever a colleague wants to communicate with another colleague, it will not communicate directly as it will produce tight coupling. Instead, colleague object will send request to the mediator and mediator will pass the request to another colleague. For example, in form creation applications, whenever a user input is provided in the text box, then the submit button should be enabled. Otherwise, if the value is empty, the submit button should be disabled. The form may evolve in future and may contain many UI elements. There may be many handling of UI elements state based on other UI elements. So it is not a good idea to make text box call the button to enable or disable. We can use a mediator here. Whenever the text box values are changed, it will notify the mediator, then mediator can notify the submit button. A real life example. A house broker may collect details of the house to be rented from the house owner. If house broker finds any tenants of interest, the broker will show the houses to the tenants. Here, instead of the house owner directly finding the tenant or tenant directly finding the house owner, there is a middleman. Memento. Without violating encapsulation, capture and externalize an object internal state so that the object can be restored to this state later. Here, the originator has a create memento operation which will create a memento instance which will contain the originator state which the client can obtain from originator and store it. Later, when originator state changes and client wants to set previous state in the originator which was stored, client can call set memento operation in originator passing the memento instance. For example, to implement undo and redo operation in a text editor application, whenever the user edits text in the text editor, its state can be saved as a memento object. When a user performs an undo operation, the latest memento instance can be used to go back to the previous state. When the user performs redo operation, the last operation which is undone can be redone. A real life example. Suppose we are creating a new recipe. Every time we record all the parameters like ingredients used, its quantity, cooking temperature, cooking time, etc. Finally, we provide a score out of 100. Say, we have reached a score of 95. In order to reach 100, we may fine tune some parameters, but let's say we got a dish which scored only 80. For our next try, we again fine tune parameters from the recipe which scored 95. Here, we record the cooking parameters as in the memento design pattern. Observer. Defines a one-to-many dependency between objects so that when one object changes state, all its dependents are notified and updated automatically. Here, subject has the reference to the observer and observer has the reference to the subject, similar to mediator pattern. Whenever the subject state changes, it will call update in every observer instance. Subject can also notify only some of its observer instances based on some condition. For example, in a chat application, the subject instance notify its observer instance whenever the user receives any message from another user. Here, the observer instances are the UI elements that must be changed whenever a message is received from another user. So the UI elements are notified. Suppose an UI element which is responsible for showing the total number of unread messages has to increase its count in this case. Some UI elements can be notified conditionally. Suppose UI elements are responsible to highlight a chat head when a new message is received from the particular user can be notified conditionally. A real life example, people can add themselves to some WhatsApp group of their interest and receive the messages posted in that group. State allows an object to alter its behavior when its internal state changes. The object will appear to change its class. Here, the context class has the reference to current state instance. Whenever the context wants to perform state specific handling, it will invoke the handle operation in the state subclass instance. The state handle operation may also change the current state of the context instance. For example, when we design a project task planning application, we can use the state design pattern to maintain the current state of the task instance. A task instance may be in different states. They are new, assigned, in progress, testing, completed. Task instance may have move operation which changes state of the task object to possible state. According to the current state, the move operation has to be performed. So task instance can call move in state instance to perform state specific operation. A real life example. In snake and ladder game, when we move to square with ladder, we will be ported to some higher numbered square. When we move to square with snake head, we will be ported to some lower numbered square. Otherwise, we have to stay in that square. Here, the player's new position depends on the type of square that player is placed after dice move. Strategy defines a family of algorithms, encapsulates each one, and make them interchangeable. Strategy lets the algorithm vary independently from the client that uses it. Here, context can be provided with any concrete strategy instance and perform algorithm can be executed on that instance. For example, in an application, we have to decide between various sorting algorithms based on the range of numbers in the integer list. If the range is smaller, then counting sort is selected, otherwise merge sort is selected. A real life example. Suppose when we are playing a chess game, we can choose to play a defense game or attacking game. Defense or attacking is the strategy. Template defines the skeleton of an algorithm in an operation, differing some steps to subclasses. Template methods lets subclasses redefine certain steps of an algorithm without changing the algorithm structure. Here, there is an abstract class which will implement the template method operation. In the template method operation, some primitive action methods are called which can be overridden in the subclass to provide specialized behavior. For example, many UI frameworks will create a UI using UI component which has some hooks like before render, after render to perform specialized actions in the subclass. A real life example. In a washing machine, we can pour detergent, fabric conditioner and start a wash program. The wash program always performs the same operation, but the detergent, fabric conditioner to use can be decided by us. Visitor represents an operation to be performed on the elements of an object structure. Visitor lets you define a new operation without changing the classes of the elements on which it operates. Here, there are two hierarchies, one for object structure and another for visitor. The client has the reference to both. The client will create the required concrete visitor class and pass that as an argument to the element class accept operation. Inside accept operation, visitor class visit concrete element is called according to the element subclass. For example, in an application, we have to implement two operations. One is we should count all the inventory, and another is we should get the total price of all inventories. For this, we can use the visitor pattern and create two visitors for these two operations. As we iterate through all the inventories, we can call the corresponding visitor for the corresponding operation. A real life example. In a hospital during doctor visit time, every patient must be visited by the doctor. A doctor specialized in a particular study should examine the corresponding patient. We can consider each doctor as a concrete visitor and patient with a particular kind of problem as concrete element. We can iterate to all the patients in the hospital and make the corresponding doctor visit that patient. Thanks. If you find this video valuable, you may share with others. If there are mistakes, please mention them in the comment section.